Okay, let's talk about HTTP. HTTP protocol is everywhere. This web page, for example, is a use HTTP as a protocol, communicate between the browser, which is a Chrome, and the server, which is a host in WordPress.com. So what is HTTP? We know HTTP involves a client and server. The client sends a HTTP request to the server. The server responds with HTTP response, and the client can choose to do whatever they like to the HTTP response. So let's take a look at some common examples. The most familiar with we already familiar with various HTTP clients. For example, Chrome and Firefox, Internet Explorer, Safari, Opera. They are running on many hardwares. Is our PC, iPad, Android, and some embedded system, such as your greenhouse, for example, your Google Home. They are HTTP clients calling some HTTP server. And HTTP client is a piece of software running on a machine. The software could be written in many languages. JavaScript, for example, is one of the language, and it could be written with C, Java, even a shell command could act as HTTP client. What is less familiar with is HTTP server. We not see the server every day. For example, WordPress.com, their server is located inside some server farms, which have probably heavily guarded with power surge protection and with a big lock on the server room, right? And those are usually powerful machines running Linux, and not necessarily powerful machines. Some server running on embedded system, they running micro C Linux, and we can also set up a server at our local. And the server is not that mysterious. I will show you later. And the server again is a piece of software that is capable of reply HTTP response. They can be written with many languages. Apache web server is written with C and C++, and many web server is written with a JavaScript running on Node.js framework. There are other popular web servers such as Tomcat and Jetty. They use Java servlet technology to respond to the HTTP request. Okay, a lot of talking. Let's take a look at some examples. Let's go W3 school, like jQuery get, right? It will bring us to this page. W3 school, let's see. And jQuery get method, it will send an HTTP GET request to a page and get a result back. So this piece of code acts as a HTTP client. It will ask the server for this resource, and once the server returns the HTTP response, and the response data will be displayed with an alert. So this is the data, and with the status get back from the server side. Let's take a look at their demo. Okay, this is the code. They use a jQuery, and once the document is ready, the button became clickable. Once we click the button, the data will be displayed. You see, this is data replied from the W3 schools server, which we don't know where they located, but they replied through the internet. It says, data, this is some text from an external ASP file. Status is success. That's all we see. And actually, we can query this. So actually, in this example, the jQuery is a client. The server we don't see, right? We don't know where it is located. We just know it's somewhere in the internet. Next, let's just demystify the server side. We can actually write a server program by ourselves. Here I use a springboot, and I wrote a server with a springboot with a Spring Framework REST controller, and here is a resource. I will talk about this later. Right now I need this, and this is a resource. When the client sends HTTP request to this resource, what this server will do is it gets a parameter, request parameter, which is ID, and it uses that ID to query the database. Once a database record is returned from the DAO, that client object is turned into a JSON format and replied to the customer. So we will query this resource and see what the result is. Let me start the server. So this is a Java program with a main function. So I run it. What it does, the Spring Framework just initialized a lot of internal variables and invoked embedded Tomcat. The Tomcat loaded the Java file, use a servlet technology to expose the REST resource on this URL. So if we are open a browser, if we query this, and we get the resource returned from the server side. So this is a server is actually hosted at my local machine. This is a piece of program written with Java, and you just see the server get my request. You query the SQL, and it's get it back. So a Java program in this case is a server side. It's a equivalent. It play equivalent role in the client server pair, same as the server mentioned here. That is a server resource in this example, and this is a server resource in this example. Actually, we queried the resource with a browser. It's not totally necessary. The client could be a different program. For example, we can use a curl command to query the same resource. So in this case, if we use curl command, we get the same result back. And the reason we are using curl, because the curl command could possibly reveal more about the HTTP request response process. So here is a curl command. Let's do a verbose mode, and you see in this case the curl command print us the exact HTTP request sent by this client, that is get host user agent accept. This is a part of a HTTP get, and this is a HTTP response from the server side. The server have a few headers, and finally, this is the server's content, right? And as we can see, the essential of the HTTP client is able to send this HTTP request. As long as this HTTP request is sent, the server side could possibly return us the right answer. So let's take a look at another example. This is a HTTP controller. I exposed this resource. Here, actually the root is also one of the resource the server side exposed. Let me show you. If I remove that, you see hello Spring Web from application YAML. The Spring Web put a resource on the default path, and it just replied me from this springboot REST controller. And we can query the same resource with curl. As you can see, hello Spring Web from application YAML. If we look at more detail with verbose, this is HTTP request, HTTP response from the server. Actually, curl is a command we are using here, but any application is able to send this string. They can get the response from the server side. So let me write a different program. Let me write a one-line HTTP client, which is able to talk with a Springboot web application. So printf, this is what I'm going to write, printf. And what we have is, we just need HTTP request /n/r/n, this line break, the second line, the second header. That means we want to get, and the resource is located at the root. Host, you see, Control V, and another line break, and user agent. It's not totally necessary, but let's add it anyway. Accept the client, accept any format, /r/n. Okay, 2//r/n. This is important. That marks the end of the HTTP request. And then we need to pipe this request into a netcat and a localhost on port 8080. That is where the server listens. Okay, let's send this request and see what happens. Again, you see the server replies the same content. Hello Spring Web from application. So the client side, as long as you can supply this HTTP GET string in plain string with 2 line break at the end with the corresponding headers, the server, which is a decent server, Springboot decent server, it replies us the HTTP response. This is a status 200 success, and these are the another headers, and this is a content of the HTTP response. So don't take this granted. Say what will happen if I just give a wrong format, not conform to the HTTP protocol. For example, I remove this training line breaks. What will happen? Nothing happens. The other side don't reply me. The other side expects those line break as part of the HTTP protocol, and we can say if we request, if we remove all the things, see what will happen. We don't include any header. We just want to say, oh, we want the get, but don't supply any headers. You see, the server side don't like it. They said, oh, HTTP 400 battle request, because you are not conform to the HTTP protocol. So in order to have a decent server reply to you, you have to follow the protocol. Be nice, include this header, include your identity, followed by this training, 9 breaks. That's a protocol. So the server replies you. Now we see the client side is nothing but a program that is able to feed this nice formatted string. The server side probably is similar. They are actually a program that is able to reply these strings, right? So let's just write a one-line server application. So let's just do that. Do while true. You know what? Let me just copy, because it's kind of a while true. Let me write a server-side program. In this case, let me use this, a different window, and let me replace the copy paste won't work because the quote is messed up. So I have to replace the quote in this case. And what this program is doing is it's in an infinite loop. Every time if anybody is trying to connect through the port 8080, the netcat will reply this string to the requester. What is inside this string? As you already guessed, HTTP response. This is a header, status header, and content type. And here is a data string. It's a shell command to return the data string. So let's run the server. This is a one-line server. Oh, what happens? Because the port 8080 already occupied by my springboot. Let me change the port. Instead of 8080, let's use 8088, a different port. Now, on the client side, we can simply say use a if print. Oh, you know what? Let's just copy this. The same client. Don't use it. Let's start with curl step by step. Let's start with browser. Maybe that's easier. Browser. Okay. Now localhost. Let's change to 088. And you see, this is a data string. And my Chrome just send a request. The request have this string get connection keep alive, and whatever other flags optional. It make so HTTP protocol is actually a big set, but in the bare minimum, you need these two at least. So let's don't use Chrome. Let's use curl and see what the minimum set of headers we need in order to send a HTTP request. So localhost port 8088, and we get the same data string as our browser does. And let's reveal the HTTP request and response. This is a request. It is sending, and this is a response. So minimum we need this, and this, and this, and the server side returns 200 OK content type. And let's do something funny. You see, the server side you don't think that's don't take it for granted. If it don't follow some protocol, a decent client program may not be happy. For example, let me remove the content type and see what will happen. And let me run this. The kernel will not complain. It will give me back the data anyway. You see, kernel is easygoing program. You cannot say the same for the Chrome. And see, oh, Chrome is also happy about that. Even though, let me make this even worse. Okay, you can still speak with this situation. Let me remove a more important part, the line break. If I remove the line break, this is not HTTP anymore. So this is not HTTP response anymore. It's not conform to the protocol. The client, kernel client, is you see, it's not happy. It didn't give me back. Oh yeah, it's happy. It still give me back something. But you know, Chrome in this case, I think Chrome not happy. Don't display you anything. And if we expect see if there are any errors, Chrome just refuse to serve you in this case. It's not HTTP protocol. Chrome don't do anything. So the server side also have some sort of rules. If you don't follow, a decent program will not be happy. So let's go back to here. Okay, we have the status, we have the content type, we have the line break marking the start of the response data. And okay, this is a good enough server side. And at the client side, we have this get. So next we can use a netcat to directly feed into this direction, feed it to this port in order to get a response back. So let's use if print printf and let's gather content in this case. /r/n line break and host /r/n. Okay, user agent /r/n, the server. The client accept anything, any format, not anything. They don't accept anything. They accept any format that what is this accept declares. Accept and it's the A. Okay, so this string is just supplied. Have the get, have the header, have user agent header. It have the accept header. Most importantly, it marks the end of the request. And so next, let's use a netcat to send this to localhost port 8088, which is server side expect. Sure enough, we get it back. Okay, so at this point, we bring the HTTP client server pair to the bare minimum. It's just a one-line program. This HTTP client just feed this request stream to a socket at localhost. This HTTP server listen to the localhost on this port on this socket and just reply HTTP response, and they both sides have to conform to a certain string format. For example, the line breaks mark the end of the header in the request. Here the line breaks marks the end of the response in the the end of the response header followed by the content of the response. And this part is necessary. It shows the response status successful 200, not necessarily 200, it could be 400 in some case. And so this basically what the HTTP client servers are. And so let's look at a picture. Client is a process send a string into socket, which is at the client side. Underneath, the TCP protocol routes those packets through the internet at the server side. The TCP package pop out from the socket, and the server gets the request response with another string, which is HTTP response string we saw here. Okay. One thing that is easy to be confused is what is HTTP compared with HTML. The HTML is a even higher level protocol. So HTTP is hypertext transfer protocol. It is above the HTTP protocol. By saying that, you see, HTTP response is the whole string, but HTML is only exist here. This string could be anything, but if this string conforms to a certain format, which HTML format dictates, then some client side could use those information to render your content beautifully. Let me show you what I mean. Okay. Let me stop the server. Here, this is a plain text server, but how about if I wrap it with HTML protocol? HTML, give it some style equal, let's say color equal green. Now I wrapped this data string inside HTML. So let me run this program again. If I use the client side to render to get a response, this is the response I'm getting back. You may think, okay, this what's the difference? Except those strange things. It will make a difference for the fancy clients like the Chrome. You see, instead of get a plain string, now it becomes green. So this is what the HTML protocol plays in. For the data replied from the HTTP response, if the data is a HTML string, it could be rendered beautifully. Let me replace this green, like say, and red, just to show you. There's nothing under my sniff. Okay, you see red. And here, let me run it. Okay, it became red. Alright, next, I mentioned at the beginning, what is this cross origin? let me show you what this course origin is. First, let's go back to this example. This JavaScript is a HTTP client. It queries this resource. We can do similar. Let me copy this content. Before I copy this content, let me replace the resource with my own resource. Instead of use 3Ws server, let me talk to my own server. Okay, let me copy this and let me create here. Let me do pwd. I'm in this directory. Let me create a jQuery.html. Let me create an HTML file. Let me copy it in wq, and then let me get this address. Let me open a window. Let me just query that jQuery HTML. As you can see, a page is rendered, same as this one. When click, this is what the response from the server side, and I can do the same thing here. When I click, this is what returned from the server side. And my data is a JSON in this case. Yeah, it's a JSON. So what you see is object. Status success. It's a 200 status. That means, and this happens because I relaxed one of the most important JavaScript security measure, which is same origin rule. There is a JavaScript engine running on the modern browsers. So when the server side replied some content, the JavaScript used those content to modify the current page, and there is a same origin rule apply. So the target server have to have the same origin as the current web page. In my case, the current web page is not hosted by this server. It is a static file. It's not hosted by the same server, so the same origin rule is violated. The modern browser, if they saw this situation, they will complain and refuse to go ahead. I have to add this annotation to relax the same origin rule. If I comment out this, and restart the server, building workspace, let me cancel first, and let me save, and let me run again. Okay, this time let me query the same resource. Nothing happens. If we see what the Chrome is doing, is complaining, okay, access control allow origin header is present in the request response, so it blocked for this cross origin request response. The same origin rule is ticked in, and don't allow me to use the resource from a different host to render the page on the current page. That's a security measure. It ticked in. We can talk more about this security rule in the future, but at this point we just be aware of the existence of those JavaScript rules, and we just go through the HTTP protocol. Have some examples. The most common example is our browser against a public server. Then we go through another example, use our browser against a local server, and we use the curl command to reveal the HTTP request and response. Once we know that, we just strip down the server-side program and the client-side program to the bare minimum. The server side is the client side is nothing but a program that is able to submit a formatted string to the server side on a particular port, and the server side, again, nothing mysterious, is some program is able to reply a string conform to a particular format, and the protocols such as line breaks are important in the HTTP protocol. If we miss them, the HTTP protocol conformed client will not be able to render them, like Chrome. They don't want to render your content. And we also talk about HTML protocol. They are the protocol exist in the HTTP response body. If the response body conform to HTML format, they are HTML formatted content, and the browser is able to use those decorators to make your web page beautiful. Finally, we use an example. We use a static file and use a jQuery to query a resource not located in the same server, and we got access control allow origin arrow, and the Chrome refused to serve the content, and that's one of the security measures burned in the modern browsers. Okay, so far so good. Let's talk about HTTP further next time.